Now that you guys have checked your homework, we're going to start 9-5 and we're going to actually solve quadratic equations by graphing. So your learning target is I can solve quadratic equations by graphing. We already know how to graph, so your warm-up is to graph y equals x squared plus 4x plus 3 and identify the vertex and the zeros of the function. Please hit pause, do the warm-up, and then I'm going to have the solution up here. Now that you've done it, this is what your solution should have been. So you should have gotten something that looks like this. And your zeros would have been right about here at -3 and right about there. So those would have been your zeros. Now the difference between a quadratic function and a quadratic equation are equations you can solve for. There's only one variable with an equation. So a quadratic function is either f of x, remember that's your function notation, is either f of x, and we're going to use x squared plus 4x plus 3, or remember f of x is a fancy way of saying y. Now whenever you make it an equation, you're going to be finding the zeros. So essentially you're going to find when y equals 0. So all we did was change y to 0. So you have 0 equals x squared plus 4x plus 3. You're going to be finding the zeros because we want to know what x has to be to make y 0. We can do that simply by graphing. So let's just go ahead, first find our axis of symmetry, which we know equals -b over 2a. If we have a here equals 1, b equals 4, c equals 3. So we'll have equals -4 over 2 times 1. So we have -4 over 2, which is just equal to -2. Then we need to find our vertex. And if you notice, this is the exact same as above. So we're just going to go ahead and use our information from above. We know our vertex is -2, -1. And this is, again, the same one from the warm-up. And we know that our y-intercept is just c, so it's 0, 3. And then we found the point 1, 8. But that's not a 0. So let's just go ahead and let's graph what we do know. We'll graph our y-intercept, our axis of symmetry first. Our vertex, -2, -1. Our y-intercept, 0, 1, 2, 3. And then we'll go over 1, 2, 1, 2. Then we knew 1, 8, 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 1, 2, 3. But we don't have the zeros. It looks like it would be where x is -1. So let's try it out and let's see what happens when x is -1. So I'm just going to plug it in and find out y equals -1 quantity squared plus 4 times -1 plus 3. So we have -1 quantity squared is 1. 4 times -1 is -4 plus 3. 1 minus 4 is -3 plus 3, which equals 0. Awesome. So we were right. It is -1, 0. So we have -1, 0, and then so we know our zeros are -1 and -3. So when we solve this equation, to make the equation make y equal to 0, it was x equals -1 and -3. So -1 and -3 are our answers, and we can see that right from the graph. Let's try a second one. Now we're going to go ahead and do this one. Now, if you notice, there's something about this. Notice that there is a GCF. If you have a GCF, factor it. And remember, what you do to one side of the equation, you could do to the other. So our GCF here is 2. Here we have a GCF equals 2. So I'm just going to divide by that GCF and get 2 divided by 2 is just x squared minus 9 equals 0. Now whenever you're graphing, we're just going to turn that 0 into a y. It just makes it easier. We know that we're going to look at the zeros for our answer, but we still have x squared minus 9 equals y. So this is the equation that we're going to be finding our axis of symmetry, etc. for. So for our axis of symmetry, we know that it's -b over 2a again. But in this case, since it's ax squared plus bx plus c equals y, there's no b, so b is just negative 0 over 2 times our a here is just 1, but 0 divided by anything is 0. So then to find our vertex, we're going to plug 0 in for x. We know it's 0 comma something, so we have y equals 0 squared minus 9, which just equals negative 9. I'm going to go ahead and start plotting the things that I know as I go. My axis of symmetry was 0, so I'm even just going to put my dashed line there. And I know that my vertex is 0, negative 9, so 0, negative 9. Now I'm going to keep going. I need to find my y-intercept. My y-intercept is when x is 0. Well, we already know it. Our y-intercept is the same thing as our vertex of 0, negative 9. So now we need to go ahead and start trying out some points. I'm going to try the ordered pair 1. So I'm going to make x equal to 1, so 1 comma something. When I plug 1 in there, let's see what I get. I get 1 squared minus 9 equals y, so that's 1 minus 9 equals y, so we get negative 8. So 1 comma negative 8. So let's go ahead and plot that. 1 negative 8, and then over 1 of the axis of symmetry, over 1, ooh, looks like it's going out. If I just kind of go along the line, it looks like it's going to hit it if I look at the trend somewhere around x equals 3. But I want to make sure. So I'm going to try 3 comma something, see what comes out. And if you can look, you know that it's x squared, so 3 squared minus 9 equals y. I don't know about you, but I'm starting to see that 9 minus 9, if that equals my y, it's definitely going to be 0. So I found the 1, 0. So I go to 3 comma 0, and then I do my axis of symmetry, 1, 2, 3, 1, 2, 3, and I found my zeros here. My zeros, again, is where it crosses the x-axis, where y equals 0. Remember, we changed 0 to y and vice versa. So I know that when I solved it, my answer is x equals, the first one over here is negative 3, and on the right, it's positive 30. Okay. Now this one here, notice it equals 36. We need it to equal 0. How could I do that? Oh, pretty simple. I can use my inverse operation. If I subtract 36 from both sides, then I have negative 4x squared minus 24x minus 36 all equals 0. Do you see a GCF? I do. First of all, my first term is negative. So I know that my GCF has to be negative. I'm going to make it negative 4. So divide everything by negative 4. All the left, all the right. Negative 4x squared divided by negative 4 is just x squared. My negative 4's cancel. Negative 24 divided by negative 4 is positive 6x. And negative 36 divided by negative 4 is going to be positive 9. And that all equals 0. So I want to find what is x when all that's 0. But for the case of graphing, let's just make that a y so that it makes it easier to graph. So x squared plus 6x plus 9 all equals y. So first let's find our axis of symmetry. We know x equals negative b over 2a. So we have negative 6 over 2 times 1, which is negative 6 over 2, which equals negative 3. So I'm going to go ahead, draw my axis of symmetry over here at negative 3. Dash it. It's not actually part of there. It's invisible. It's just my line of symmetry. And then find my vertex. So plug negative 3 in. So I have negative 3 comma something. So it'll be negative 3 quantity squared plus 6 times negative 3 plus 9 all equals y. Negative 3 quantity squared is 9 plus 6 times negative 3 is negative 18 plus 9 equals y. If you add all these up, you get 0 equals y. Negative 3 comma 0. It looks like we've had one of zeros. Negative 3 comma 0 is right about here. Now let's go ahead and find our y-intercept. Our y-intercept is just simply going to be 0 comma 9. So 0 comma, 9. And then 1, 2, 3, 1, 2, 3. Is your graph ever going to go below here? No, it's going up. So I'm going to have a graph that looks like this. There's only 1, 0, and that's okay. And this is x equals negative 3. That's the only place, that's the only number that's going to make y equal to 0 because it touches the x-axis. So we've done 2 zeros, 1 0. Let's do a third case. This one again is not equal to 0. So let's add 3 and add 3. So you get 2x squared plus 4x plus 3 equals 0. Is there a GCF? I don't see it. I don't know about you. So let's just go ahead and get started. Our axis of symmetry is going to equal negative 4 over 2 times 2, which is negative 4 over 4, which equals negative 1. Let's go ahead and draw it. Negative 1 dash 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 dash. So we have it equal to negative 1. Then our vertex is going to be negative 1 comma something. So you have 2 times negative 1 quantity squared plus 4 times negative 1 plus 3 all equals y. So remember your 0 is really your y. So we have 2 times 1 minus 4 plus 3 equals y, which is 2 minus 4 plus 3 equals y. So you end up with 1. 2 minus 4 is negative 2 plus 3 equals y, which is 1 equals y. So you end up with negative 1 comma 1. Negative 1 comma 1. Right there. Now let's do our y-intercept. Our y-intercept is just 0 comma 3. So remember, it's just your c. Oh, look at it's going up. For the case of this, does it ever touch the x-axis? No, it never touches. So there are never touches the x-axis. So there are no solutions. So your answer is that there's none. So you can see there can be 2 zeros, 1 0, or no zeros. Now let's do a fun word problem. A frog jumps up straight from the ground. The quadratic f of t, or I'm just going to rewrite it as y equals negative 16t squared plus 32t, models the frog's height above the ground after t seconds. About how long is the frog in the air? This is 2. It's kind of hard to tell. So if I think about this, a frog goes up and comes down. This right here is his time. So, ooh, isn't that a 0 and that a 0? So we need to figure that out. Let's just go ahead and graph it and find the zeros, because we have to find the zeros. So let's graph it. We know that the axis of symmetry equals negative 32, because that's our b, over 2a, which is 16, which is negative 32 over 32, which equals, this is negative 16 over negative 32 equals positive 1. Now, I'm going to go ahead and just use the first quadrant. And we know that this is your time, and this is the height of your frog. So our axis of symmetry is 1. So I'm going to go ahead and go 1, 2, 3, 4, make a dashed line up here at 1. I don't know any heights yet, so let's go ahead and let's find our vertex. So we know, now think about it, our axis of symmetry, that vertex is going to be the middle. That's going to be the highest point. So when I plug it in, my vertex is going to be 1 comma something. So I'll have y equals negative 16 times 1 squared plus 32 times 1, which is negative 16 plus 32, which equals 16. So 1 comma 16. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and make a point. Now think about this. If we get our y-intercept, notice that there is no c. So I'm going to put a plus 0. So we know that that is